This one is about AS path prepending. So imagine we're a big video provider, like maybe Netflix, and there's a lot of traffic generated by autonomous system 500 towards us, and they can reach us either directly through R1, or they can reach us through R2, going a little bit around, first reaching AS 200 and then going to 100. And imagine that we're doing some analysis, and it turns out that this traffic is mostly generated to our servers through R1, overloading that link here between R1 and int1. So let's go ahead and see. Show IP BGP regular expression, and the prefixes we advertise ourselves. This is our regular expressions for that. And these are 4 big server farms, and we generate this traffic here on this link that is overloading the circuit here a little bit. So we want to influence the packets coming back to Internet 1, so that half of the traffic is sent across through R1 and half of the traffic is coming through another link, maybe over the internet through AS200 and back to us. So this is where AS path prepending can try to influence the path. However, this can always be actually overridden. So if R1 or AS500 decides to do otherwise, they can. Why is that? Because the AS path prepending, or the shortest path that we use towards the destination, is actually the 4th parameter tested. So if, for example, R1 decides to use local preference, they can always override our attempt. But this is a suggestion, and this is the first actually parameter checked if nothing is changed in AS500 towards our destinations. If there's no wait, no local preference, then this is going to be our first test, really, and this is how I'm going to influence the packets. So let's just say that those 4 destinations are available, and if R1, let's say, checks them, show IP BGP regular expression from autonomous system 100, it's a direct connection, and R2, currently, I remove the previous configurations which influence the path, show IP BGP regular expression 100, and we're going through R1. So all the traffic towards all 4 server farms that we advertise in AS100 are now reachable through R1, and that link is being overloaded. So let's spread the traffic a little bit. What I'm going to do, okay, let's look at the path. So R2 has currently an alternate path towards those video servers, but that alternate path is not going to be chosen for any of those 4 prefixes, because the path is 2 hops versus 1 hop. 1 hop always wins, and there's nothing changed in AS500. So here's what I'm going to do. I'm going to go to my internet one, and I'm going to create a 2 prefix list. Actually, 1 will do. IP prefix list. I'll call this video 1, and I'm gonna do permit statements covering those 2 prefixes. Let's say these 2 prefixes, and I'm gonna say permit 100.1.10.2.0. We're going to be checking the first 23 bits, so that matches 2 and 3, and we've already seen that in one of the videos. But the prefixes themselves are 24 bits in length, so that's going to match on both 100.10.20/24 and 100.10.3.0/24. Now I'm going to create a route map. Whoops. Route map. I'll call this AS path permit 10, and I'm going to match on this prefix list. Match IP address prefix list video 1. For this particular prefix list, which means for these two prefixes, I'm going to set ASPath prepend, and I will add my own autonomous system a couple of times. So the minimum number I should ask to influence the AS500, let's go back to R2, is to increase the AS number or length of the path towards those destinations so that there's more than 2 hops. Currently they have 1 hop and 2 hops. It's always kind of guessing. It's always trying trial and error, see if it works. So what I'm going to do is I'm going to prepend my own autonomous system maybe 3 times. That should do the trick. So 1 is the default plus 3 more. That's going to be 4 hops. 4 versus 2. 2 is better than 4, so the R2 should potentially use the secondary path towards my video servers. And what I'm going to do now, of course, if I apply this route map towards R1, increasing the length of the path towards those 2 destinations, I need to still advertise the remaining 2, the remaining prefixes unchanged. That's why I need to use the same route map and permit, let's say, 999, for example, so I can leave a lot of room for new statements there. And as a result of that, router BGP 100 process for the neighbor, and R1 is 10.1.10.1, I will apply the route map called ASPath. And in outbound direction, of course. So when I'm advertising those prefixes out towards the R1, this is where the prepending is going to happen. So let's see that now. What I'm going to do before because it's not applied yet, I need to actually send the advertisement towards R1. Let's go back to R1, check what the path is. This is the path. Check what okay, yeah, we're good. And now I'm going to say clear IP BGP for neighbor 10.1.10.1 outbound. I'm going to be sending my BGP table one more time. When I do that, let's repeat what happened. So R1 now is receiving for those 2 destinations 100.10.2 and 3. The path is actually better now via R2. This is the next hub address on R2 pointing to Internet 2. Now, is it reachable at all? So show IP route. Let's verify. Yes, it is connected via static route. It's better actually to do that this way. So what I prefer to do, because that I'm using default route to reach that destination. What's better to do actually on R2, and when I have a neighbor relationship, so do show run section router BGP. What I'm going to do for my 1111, I'm going to use next hop self command. That's what's missing here. Okay, let's fix that real quick. So router BGP 500 neighbor 1.1.1.1 next hop self. I prefer that kind of thing. So I see the gateway actually 1.1.1.1 rather than static route. So if I go back again here and clear IP BGP 2.2.2 and inbound. So when I'm going to do this, I can see now my gateway is 2.2.2.2 on R1 towards those destinations. So now the path is different. So if I, let's say, just go here to R2, and I'll repeat my command here for destinations 110.2, the next hop or the best path is going to be this. And routers in BGP only advertise the best path. So now in my picture, R4, R5 are receiving the same information. Let's see that actually. So what is the situation on R4, for example, towards those destinations? Show IP BGP regular expression originated by 100. And sure enough, for these first two prefixes, video servers, we use R1 as the next hop. For the remaining two, R2 is the next hop, and that's what's going to be installed in the routing table. So show IP route BGP, that's what's showing in the table. And that's how we can influence the path towards those video servers. But again, it's only suggestions. So final test is trace route towards 100.10.0.1 should go through R1, and it is through R1 and reaches the system. But for the 2 and 3, we're going through R2. So we're going to R2, Internet 2, and we end up on those servers right there. So that's what AES path prepending is all about.